Okay, so let's discuss where we are to this point. Well, to this point we've talked about the fact that whenever we have a pair of parallel lines that are cut by a transversal, there's a bunch of special angle pairs that are created. Which ones are congruent? Well, we talked about the fact that alternate interior angles are congruent. We talked about alternate exterior angles being congruent. We talked about the fact that anytime we have two angles that share the same vertex but they don't share any of the same sides, they're congruent. Those are vertical angles. Those are always congruent. And then the last one of the four that we talked about that are always congruent in this situation are corresponding angles. How about when we talked about the angle pairs that were supplementary? Well, what's left? Same side interior, same side exterior. Each of those special angle pairs add to 180. And then we also had the linear pair. Whoa, what happened there? Linear pair, those are supplementary. Now, of those, which angle pair was always congruent? Regardless of whether or not we had a situation like the one I already drew, or even if we had a pair of lines that were like this, that were not parallel, but crossed by a transversal. Well, alternate interiors in that case are not congruent. Neither are alternate exteriors in that case. And corresponding angles are not congruent in that case. The only pair that is still congruent even in a situation like that are the vertical angles. That would be a situation like this angle and this angle. Okay? Those are vertical and those are congruent. And which pair are always supplementary regardless? Well, in the bottom situation, same side interiors are not supplementary, neither are same side exteriors. Those are the linear pairs. The linear pair down there, or anywhere, anytime you have a linear pair, they're always supplementary. So let's put this all together. Well, you're going to have so many situations where they just give you a picture and they ask you to set up an equation and solve to find x, y, or some other variable. The question you have to ask yourself is, okay, this angle and this angle, what is the special type of angle pair that we have? And in this case, the special angle pair are alternate interiors. And what we know about alternate interiors is that alternate interiors are always congruent whenever we have parallel lines cut by a transversal. So, because they are congruent, that means equal. I can take 2x minus 10 and set that equal to 3x minus 40. Now, don't think that you can always set them equal, because we can't always set them equal. We can only set them equal when they are congruent. So a quick couple of steps here. I'm going to subtract 2x. Those cancel. I'm going to bring down the negative 10. Over here, 3x's minus 2x's is 1x. And I'll do a quick little adding of 40 to both sides to get that x by itself. And I get an x value of 30. So x is equal to 30. If I want to know the measure of each angle, I'm just going to take this 30 and I'm going to plug it right in for x. 2 times 30 is 60. 60 minus 50, or 60 minus 10 is 50. Okay, if I were to do the same thing for the other angle, 3 times 30 is 90. 90 minus 40 is also 50. Great way to check your answer. Both of those degree measures are 50, which they should be because they are congruent. Next example. Different type of angle pair. When I look at these angles, and I look at this angle here and this angle here, I don't know why that put an X through that, or a line through that. Weird. Okay, now I ask myself, okay, what are these? Well, these are corresponding angles. Right? They slide right up the transversal. So these are our corresponding. And what we know about corresponding angles in a situation where we have parallel lines cut by a transversal, those are also congruent. So because those are congruent, once again, I can set these equal to each other. 4x minus 30 equals 2x minus 14. I'm going to do a couple steps here, get all my x's on one side. This time I'm going to subtract the 2x and bring all the x's over here. So 4x's minus 2x's is 2x minus 30. Bring down the negative 14. I'm going to move all my constants to the other side now, so I'm going to add 30. So now I bring down the 2x, and that's going to equal 16. Then if I divide both sides by 2, I get an x value of 8. So x is equal to 8. If I want to know the measure of each angle, I'm going to take that 8, plug it right in here. 4 times 8 is 32. 32 minus 30 is 8. If I take that 8 and put it here, did I do some improper math here somewhere? Yes, I did. Last I checked, when I do 32 minus 30, that is not 8, that is 2. Sorry about that. So then when I plug it into the second angle, 8 times 2 is 16. 16 minus 14 is also 2. 2 degrees is a super small angle. Never would have guessed that looking at the picture. That's why we never trust the pictures. Never trust the picture. Okay, and then third example. Here we have an angle pair. Same side interiors, right? They're on the same side of the transversal. They're both on the interior. Same side interiors. Well, same side interiors are not congruent. Same side interiors are supplementary. So I cannot set these two angles equal to each other. Instead, I have to do 5x minus 32, which is the first angle, plus x plus 8, which is the second angle, equals 180. So you're not always setting the two angles equal to each other. You have to ask yourself, are they congruent or are they supplementary? Now, in a situation like this, I'm still seeing some Algebra 1 mistakes on these types of problems. Remember, same side of the equal sign. If you have like terms, you can combine them. So I have a 5x plus a 1x. On the same side, that's a 6x. Then I have a negative 32, this was a plus 8, that's a negative 24. Equals 180. Going to do a little arithmetic here. I'm going to add 24 to both sides. And I get 6x equaling 204. And now I'm going to divide both sides by 6. I don't have a calculator in front of me, so I'm going to go old school, and I'm going to do 204 divided by 6. I ask myself, how many times does 6 go into 20? That's 3 times. 3 times 6 is 18. I subtract down, that's 2. I bring down the 4, that's 24. 6 goes into 24 4 times. X equals 34. Old school division. Then when I want to know the measure of each angle, if I take that 34 and put it right here, 34 plus 8 is 42 degrees. And since these are supplementary, I know if I do 180 minus that 42, that's going to give me my other angle, which is a 138. Those are my two angles.